Well, well, well. If it isn't my chat, shut up. If it isn't my chit chat, my gang, my people, enter, send now. Done. I don't know what this is. Hi, Code Toil. Okay. Let me just boot up a few more things here. Okay. Twitch, done. Let's turn on some YouTubes. Get some audio going. Get some little bit of moolah, a little bit of zuzuboo, a little bit of magic. What did we listen to yesterday? We listened to Star Guardian or something, right? I feel like we should let me pull up. So that's my stream. We did not OpenGL. We did Lo-Fi Leah yesterday. I feel like we should do something else. Let's do... No, we didn't do Lo-Fi Leah. We did Star Guardian. Yeah, that's right. Let's do some Lo-Fi Leah. Turn on some Season 5. Get a little Nisei Monogatari music. Wolfie! Hi there, Wolfie! How's it going? He's staring. Stare. Wait, where's my camera? Not that. That. Stare. Hi, hello. Let me just change one last thing here, and we are good to go. All right, let's shrink myself here back to size. And what, like right there is good enough probably. I feel a little bit hunched over, but that's okay. All right, so let's talk about where we're at with the project. So now we have access to all the original functions via linking a GLAD library we downloaded. Makes it pretty easy. Do I even need the SDL OpenGL stuff? I don't think I do. We have SDL GL swap window, but do we have another swap? Maybe not. Maybe we do only have SDL GL swap window, but in any case, let's do this. I'm suffering from bad internet. Oh no, Wolfie, why? How's it going, by the way? Oh my goodness. Besides suffering from bad internet, how's life? Okay, so today is the day we're gonna build a goddamn triangle. So right now, the whole program works. What? Truncation from double to GL float. Oh, that's different. Like that? Interesting. Does that fix it? Unresolved external symbol. Uh-oh. Uh-oh. We have a bit of an issue. Never mind. Hold on. We're having unresolved external symbol linking error. Uh-oh. That's not good. Oh, doing okay. There's some stresses, but it'll pass. And you, streamer? I'm doing great. We start classes in 7 days on the dot. So 7 days from now, I'll be starting class. So we're going to do the first exercises together because there's like a non-graded self-study thing. So we'll just do that on stream. And then all the graded stuff I'll do off stream. I'm still debating whether or not, because part of my like requirement for a degree is that I grade some other people's work, not in the same class or anything, but like other stuff that I've already done. I don't know when we're going to do the grading of the homework because it is anonymous. So I'm wondering if we do that on stream or not. I don't know. Debugging hours? Oh, hot. Who doesn't love good old debugging? We're having a bit of an issue. We have unresolved external symbols now, which tells me it is a linker error. Which is this. So instead of that, should I just hashtag? No, I don't need to hashtag include. We just have importing. Although I probably should just include glad/glad.header. We'll just see if that solves it. It does not. Okay. Okay. Dun 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 dun. Project properties, linker. Additional library directories. Additional library directories. So this include is here, right? Now does it work? No, still unresolved external symbols. Okay, so now we're back to defaults. I'm still having issues. With linkers. Slink phone. Ads purgatory. Oh no. Well, you don't only get ads at the beginning. Right? I never play ads ever on stream. So once you're in, baby. You're in for good skis. Welcome. Okay, so we're having a bit of an issue with linkers right now. The system, the import system does read that I have the header, right? And I'm able to access these functions that are in that header, like GL gen buffers. The problem is when I actually compile, I get the error of link 2001 unresolved external symbol. So I guess we'll just... Ugh. Okay, highlight. Copy. Let's, Oh, shit. Oh, I just canceled my music. Oh, no. Oh, disaster. Hold on. Phoenix Wright, Ace Attorney. Go. But TLDR, you only get ads once. Oh, no! Oh, yeah, we only get ads once. That's it. I just haven't played on stream intro and then you never again. I think it's unfair to play a lot when I'm barely a double-digit Andy. Did I just pin that again? I don't even know how I pinned that. Unpin. How do I even... It must be a shortcut I'm missing. Linker tools error. The compile code makes a reference or call to a symbol. The symbol isn't defined by any libraries. This error message is followed by linker 1120, which is there, and that's resolved when these are resolved. And this is all linker 2001 errors. So there are many ways to get 2001 errors. All of them involve a reference to a function or variable that the linker can't resolve or find the definition for. The compiler can identify when your code doesn't declare a symbol, but not when it doesn't define one. Oh, so we've declared it, but we haven't defined it. That's because the definition may be in a different source file or library. If your code refers to a symbol, but it's never defined, the linker generates an error. Okay, so we are able to find the functions, but not the definitions. Okay, so that is a... So we have as a dependency that library. So that exists. So now we have an issue. But it's already a dependency, right? Okay. We declare a symbol, but we're not defining one, even though it's a dependency. So how do I define it? Well... No. Module definition file is the only thing I would see there. But we already have our dependencies. I didn't override anything. All the additional dependencies are there. Use library dependency inputs. Specifies whether or not the inputs to the librarian tool are used rather than the library file itself when linking to library outputs. Yeah, it doesn't matter. So we already have the file linked, but how do I define it? That's what the glad.c file is for. Add it in your project to compile it. Add it. So like import glad / but I only have a header. Is there another way to import it and I just don't realize it? So desktop, programming, tutorial, include. So I have those two headers, and then I have the, hold on. Then I have the source file that's a C-based file. Drag and drop it in your project in the Solution Explorer. Oh, it's that easy? Oh my God, based. Okay, that's kind of cool. So just drag and drop it to the source files, and now we're good, right? So run it. Oops. Oh my God, thank you. Okay, we still have errors, but thank you, that helped. Okay, I didn't know you had to do that. Unrecognized flags, scan dependencies, OpenGL debug, and C1. Argument truncation. Okay, let's get rid of these warnings here. Let's just, let's be warning free. We'll just cast this as a GL float, which is super goofy, but whatever. Okay, so now we have a crash. No message, so it wasn't a context, and there's no error for the message we have. We just have a random crash. So, error C1007, unrecognized flag. Scan dependencies. Okay, that's awkward. Just in C1, anywhere in here? Oh God. Oh, Jesus Christ. That's awkward. So how do I solve that issue? Do we just run the debug, I guess? Okay, right here. GL bind buffer, exception thrown. Access violation, executing location. Oh, this is a bind buffer issue. But we know it works because we've generated the buffer, right? So this is the exception thrown. I think that means that we generated the buffer, but we never actually defined it, right? So here, I guess we can test this. Standard print line. Oh God, I hate that. Print line, VBO. Let's just print that VBO. Oh, never mind, it doesn't print. Oh, shit. So it's this that's throwing the exception. Access executing violation. Access violation, executing location, memory 0. So I'm accessing void or something? Oh. You know what? Actually, I know what I should do. I should do this. If this does it something it shouldn't, then this. Wait, it doesn't have a bool type? Huh. Interesting. So that's a definition. So maybe we should just call the original function? Okay. No, still are throwing exceptions. Glad needs to be initialized before it's used. Didn't we already do that though by importing Glad? Does this not initialize the library? Does Glad have specific initialization requirements? No, it doesn't. Hold on. Let me just quickly here. I thought Glad was just a set of definitions. That's all I thought it was. Using OpenGL, obviously. Init names, components, memory, get. Yeah, we're not using any. Yeah, we're not even getting to the loop. We're just. Actually, this should be Glad. Clear color. I don't know how much I like prefacing everything with Glad, but if it's not the issue, I really want to avoid it. I want this to be as like generic as possible. All the GL functions are just function pointers that need to be set by Glad at runtime. Wait, kind of like, well, I guess it's not. I was about to say it's kind of like an interpreter instead of a compiler, huh? But it's not that. I bet you need to call a function, but don't. I guess we can just Google it. Yep. Fatal error. To set this, you can refer to the document, select the configuration properties, C++, command line property page, in additional options, add /that, and okay, but that's specific to this dude's library, so mine's gonna be different. Okay, so let's try it. So, configuration properties. I'm assuming it's just project properties. Oh, wait, no, it isn't. Project, configure startup projects. No. Yeah, it's properties. C++. What did he say it was? Command line property. Command line. Oh, shit. This is new. Additional options. So... unrecognized flag. So what flag do I have? So I need to set the flag to that. Is it /src/gladc? I know it's really small text for you guys. Scan dependencies. OpenGL. No, that's not it. Glad load GL, glad load func, SDL get proc address. What is that? What that booty do though? Thank you. I haven't seen it here before, I think. Is this it? Load func is undefined. SDL get progress needs a parentheses. Okay, now glad load GL is defined. Glad load func is undefined. I'm guessing... is that a function? Wait, no, it doesn't need another parentheses. What the fuck? Was this, what's going on here? Oh, you no, it's the same. I bet you need to call a function to initialize glad. What? Why? Load GL. Glad load func. So what does this require? C++ glad failing to initialize. Glad loader. If this, then failed to initialize glad. Get proc address. Okay, I see where you're going with this. Uh-huh. Window, create window, null, loader. Okay, we don't have that problem. You never made a GL context via make current context current. Unlike other GL windowing frameworks, GLFUW doesn't have GL context current when create window succeeds. Well, we don't have that problem. We have a context called context, which is then loaded in the game loop as GL context. So that's loaded. Do we do something with that? Gary, look at the Discord. In the previous chapter, we mentioned that glad manages function pointers for OpenGL, so we want to initialize glad before we call any OpenGL functions. This function. We pass glad the function to load the address of the OpenGL function pointers, which is OS specific. It gives us this get proc address that defines the correct function based on the OS we're compiling for. So that's good, but that doesn't really solve our problem because we're already calling this function, load GL. So that's what we should be calling. Then we have glad load func, which is currently undefined. So that's an issue right now. Do I even have anything like that? We have glad load proc, glad load GL, GLES1 loader, but no func. What about like glad func? Glad GL. Yeah, we don't have anything like that. Yeah, we don't have like a load func. And then we have SDL get proc address, but that might be just a, it might just be an issue with getting the function from SDL with another, like, import. Try removing the cast. Where do I cast anything? This? That shouldn't matter. Whoops. Yeah, we still need this, though. Glad loader, glad load proc, SDL get proc address. Oh, that worked. Glad load GL loader, glad load proc, SDL get proc address. What the fuck? Oh my god, what that booty, though? Okay, how did you come in here with your just... Listen, when you came in here, here's what I heard. That was your giant schlong slamming on the table, being like, bitches, please, I got this in the bag. Thank you, I appreciate that. Let me multitask here. Cool, we did it. Okay, well, haha, I did a lot. That's awesome. Okay, so initialize glad, make vertex, or we'll just say vertex info. We should make a separate class. Oh, no, we do have a class for that. Then we have our class for our shape. And then we have our shape array. So that's it. We did it. All right, let's make a fucking triangle, boys. Wow, you heard that from over there? Hell yeah. Thank you, what that booty do, though. I appreciate it. All right, let's draw a motherfucking triangle. It's time. OpenGL learn. Okay, so we got quite a bit further here. Now that we have all of our functions and everything linked correctly, let's make a triangle. Okay, so we already went over the rendering pipeline yesterday and the day before. So this is our current window. Ooh, very nice. We opted for a borderless window because I think that just looks better. And we're using SDL because I've made multiple games in SDL and they're wonderful and they're simple, but now we're stepping away from the simple SDL renderer and into the realm of, you know, homegrown engine. Okay, triangle. We already have our gen buffers, our buffer data. Buffer data is here. And we're casting, where's the info at? Yeah, we're casting these as GL floats instead of doubles, just to ignore warnings. Because right now we have one error still, but we'll ignore that. We'll ignore that one error. We don't have a problem with that, right? So anyway, sweet. This is, we'll say, render pipeline for triangle. Trying to get better about commenting. Okay, let's actually make a fucking triangle. Zoom in. Ooh, vector graphics. Okay, buffer data. We talked about the difference between stream drawing, static drawing, and dynamic drawing in that it's different rendering contexts for different items on the screen. So if you're talking like, where's Path of Exile? That's like a good one to talk about, right? It's like perfect for what we're talking about. Path of Exile UI. Can I get the in-game? Is this the best we're gonna get? Okay, that's good enough. Okay, so this is the most I can zoom in on Path of Exile, but this is like a great example of how we can talk about streaming, static, and dynamic drawing for the renderer, right? So a stream draw is you have something to render, but you only want to render it like once, and that's it, or at minimal amount of times, right? You're not going to give it a bunch of different information all the time. It's more like a set it and forget it kind of situation. The UI of the game is a great example of that. So these little columns here, the in-between buttons, maybe these help menus that pop up. That's an example of I think it's static, right? Your stream. That's an example of a stream, right? Just give it info, it'll render. It's not going to spend too much time on it, which is fine because a lot of the game is that, and you don't want to waste resources. You know that? Or, you know? So static draw, the next one up is you only use a set once, but it's used many, many times. So, ooh, actually, I'm trying to think now. Maybe that's not correct. Or maybe that's like font, or maybe that's like the health bar or something, or maybe the mini map. Actually, that's not true at all. Actually, I wonder what is an example of a streaming data. Like maybe I'm thinking about this incorrectly because this is a video game. I wonder if stream draw is something like you're making an application, like a calculator or something, and the calculator, like the numbers on the screen, because you don't need to refresh the frame, you know, 120 times a second. It's just once until the user does something. Maybe that's an example of a stream draw, whereas static draw is you only have one set of data like the UI, but you have to draw it many, many, many times. And that's why we have a stream draw. No, fuck, we do have a static draw. Okay, that's right. Yes, I was right. Okay, I overcomplicated it. I was right. It's a static draw or simple triangle. This UI would also be a static draw then. And then dynamic draw is information is like changing constantly and you have to like spend the most amount of resources on it. That's like the whole game, right? You're moving, your character's doing stuff, animations are playing. These are all very dynamic and you have to be on top of it. Okay, whew. I understand. Okay, we are now rendering masters. Gotcha. The position in the data of the triangle does not change, is used a lot because we're rendering it like, well, we don't have a frame cap right now, so it's like 5,000 times a second, our poor 4090 is just gonna get taxed, but it's okay. And stays the same for every render call, so its usage type should best be GL static draw. If, for instance, one would have a buffer with data that is likely to change frequently, a usage type of GL dynamic draw ensures the graphics card will place the data in memory that allows for faster writes. And that's the whole point of this function, right? Or these functions, right? This generate a buffer, the bind the buffer, and then buffer data with what kind of draw we want. All this is doing, this whole step, is just reserving memory on your GPU for whatever we want to render, because we don't want to tax our CPU every frame by like, hey, GPU, we want to render this on the screen. We want to skip that step. The GPU is just gonna remember everything. It's a certain amount of space you have, but it's gonna remember everything you put into it, and that's what we're doing here. That's it. We're just memory management. And that's C++, right? As of now, we stored the vertex data within the memory on the graphics card as managed by the vertex buffer object name VBO. Next, we want to create a vertex and fragment shader that actually processes this data, so let's start building those. All right, next step in the render pipeline, vertex shaders. Ooh. Real quick though, I want to print line. God damn it. Standard. Print line. The text is all goofy because I'm super zoomed in for you guys for Visual Studio, so that's why it's kind of silly. All I want to do is just print VBO. I want to see what it looks like. 1. Oh, it is just 1. Okay, sweet. So that's what we are here. Okay, so it is whatever number I give it. In this case, it's 1 object long. Okay. So if I wanted to generate an object with, say, 6 triangles, and we want them to be like, or 4 triangles, I guess. If you want it to be like a hexagon, hexagons are 4 triangles, right? So you have 4 triangles, you would have 4, and now it would reserve 1. I guess I don't understand that. I wonder what the difference is there. Okay, well, shit. Learn something every day. The vertex shader is one of the shaders that are programmable by people like us. Modern OpenGL requires that we at least set up a vertex and fragment shader if we want to do some rendering, so we will briefly introduce shaders and configure 2 very simple shaders for drawing our first triangle. The next chapter we'll discuss. So now we have to make our own shader, right? OpenGL doesn't, it's not like OpenGL's not a video game engine, okay? We can't just be like, ooh, do the blue shader. You have to actually make the shader or download it online. But because I'm taking a class on computer graphics, I'm gonna have to make my own shaders. The number in gen buffers is the amount of buffers you want. The 1 in VBO is just its ID that was given by the OpenGL driver. Oh, okay, that's kind of hot, what the fuck, blub. So I guess my question is what kind of object uses more than 1 buffer? I guess that's my question. What is an object in OpenGL that would require more than 1 buffer? Anyway, the first thing you need to do is write the vertex shader in the shader language GLSL, OpenGL shading language, and then compile this shader so we can use it in our application. Below you'll find the source code for a very basic shader. Okay, so this needs to be rendered, and then we have, let me get this in order, okay? We have to have a separate file that's C++ in this case, or no, not C++. What are we saving this as? Is it a .c file? So we have this text exactly laid out, and then we compile it, which I'm assuming it's not a .exe, and then we're gonna put it in the file and then link it? Is that how we're gonna do this? I'm not used to doing like separate language integration. This is very new to me. I'm used to just doing everything in C++. It's not a single object, it just lets you allocate multiple buffers in one shot. Oh, okay. So every time you need a buffer, rather than having like individual unsigned ints as like thousands of them, you can just have one big allocation. Okay, I got you. So, I guess we can look this up. Learn OpenGL link shader Reddit. I just got to the shader section, have a really nice time understanding a lot. Originally, a shader was a piece of code that simply manipulated your geometry and rendered it onto the screen. Nowadays, you can use shaders for way more than that. In the case of graphic languages, shaders allow you to communicate with the GPU, thus freeing your CPU from heavy work by delegating it to the GPU. Updating animation, post-processing images, culling computations are all done in the GPU via shaders. Didn't know that. I've only ever done CPU-based updating animations, so that's kind of cool. The tricky thing about shaders is their programming. You need to know their restrictions and what you want them to do with your data. I believe at the end of the shader chapter, they address one of your comments that talks about the big block of shader code at top of main. After everything's all done, they walk you through building a shader class that lets you load them from file. I think using the C++ standard library. Thinking about vertex attributes still gives me a migraine. I don't think it's that complicated. Reference script. Okay. Class vertex shader public. Oh. Ah, do I really want a multiple classes of shaders and then call them in? The only way to add a GLSL script is by making a constant character pointer list at the top of the main script? No. Can't link shaders. By the way, have you seen the other screenshot on the Discord that I posted? Yeah, what is that? Hold on. I've seen this, but what is this? I see Game 3D Launcher. Is this you, like, fucking slamming your balls in my face with like, hey, I know OpenGL more than you? In which case, based. But yeah, I'm learning. Did I just pin that? Oh my God, I can't. Chat, I don't know how I pin things. I'm so sorry. I don't unpin. Game 3D is my game. Ooh, that's spicy. If we ever made a game on ours, we would just do elements the game, right? Or in OpenGL, I could do, can I just run the .exe? Oh, do I have a release version yet? I don't even know. I guess I could just run this real quick. Oh, that was a mistake. Hold on. I really shouldn't open that file like that. That's better. Okay. Now run. So this is our current game in SDL 2, which I think is pretty great. And we have like cards and shit that are visible. Oh, it's so nice. Oh, there's no more temp art. I have art for everything. I just haven't like given it yet. We're getting pretty far with the game. I'm expecting the game to be done soonish. We can draw cards. We can play them. Ooh. Did I really brick? Anyway, look, we have little animations. So now when he plays a card, look, we have little glowies. Oh my goodness. So exciting. Anyway, this is where I'm at with our game. But all of this is done in the SDL2 renderer. Not even SDL3, it's SDL2. And it's fine. Like we can grab the Steam ID, Steam picture, all that good stuff. And we can get the enemy's picture and everything for their Steam ID. The thing is as I learn to program better and better, I want to make this in OpenGL. And the reason why is because this whole game is made without shaders. Now, let me zoom in on something real quick, because maybe if you're clever, you've caught it. You guys see very slightly around this square, there's a shadow. That is not a shader. This is hand-drawn, hard-programmed shadows. We have an add border function. So let me zoom in a little more, I guess. Whoop. So you can see there's a little shadow around this. These are actually like hard-coded like transparency in order, like that kind of loop. So it would be nice to have real, like actual shaders for the game, just to make it look better, you know? But, oh my God, look at that art though. It's so pretty. Anyway, this is as far as we are with the game right now. I want to have him do stuff so you can see more cards here. Can you not brick? Oh my God, he totally bricked, didn't he? Okay, thank God. So now as he goes through, she used an ability, but right now spawn monsters function is turned off because we need to refactor spawn creature abilities, because right now the events aren't completely programmed right. Well, they work, but it's more so that I'm having a brick wall of just not a brick wall, but I'm definitely eating the complexity cost of how I set up that switch statement, and it's taken so long to have individual things now. Anyway, this is our little game. Very cool. All right, let's get back to OpenGL. Jeez, stop distracting me, chat. What's that noise? Hold on. Oh, it's my air conditioner. I didn't even... Jeez, that was so loud. I was like, what's that noise? It's like this buzzing sound. I thought it was my computer. Okay, OpenGL. So we have our buffer data, we reserve memory, all that stuff. Now we need to... Okay, this guy's using SDL. Thank you. Initialize SDL in OpenGL, create a context. I call a function that passes the names of my vertex and fragment shader files, which creates a program object, which then it creates a vertex shader and then a fragment shader. Jesus. I guess what I'm confused about is, can I just make a class object instead of calling void main? Like, this comes across very like procedural kind of programming, not object-oriented programming. Okay, I guess we can just copy and paste this. I'm just worried that when we render the... Okay, here's my question. Maybe I don't understand. What I don't understand is that it says this is in the language of GLSL, but when I render this, it's gonna end up being a .exe, isn't it? Which is not what I want. Game 3D is my game. Hell yeah. Also, the launcher was written in C# with WinUI, and the game itself was written in TypeScript with Babylon JavaScript. You know what's funny is I was looking through all of my programming language learning in all of my classes. Turns out I do learn C++ in my algorithm courses. They require C++. I thought that was kind of cool, but whatever. I haven't touched too far into that yet. I'd like to take discrete math first, but we have to learn JavaScript, Java, Python, SQL, PHP, HTML, CSS, R for stats, or R for statistics, and one more I'm forgetting. But at no point do we ever touch C#, which I think that's kind of cute. Shaders are a simple language. There's no classes. Oh shit. Wait, is the shader language not Turing complete or whatever? Does that make sense? Am I understanding that correctly? This is not a Turing complete language, right? You guys understand what I'm saying? GLSL does not support classes and more generally object orientation. You give the GPU the shader code and the GPU compiles it in memory. You don't compile anything yourself. Wait, so all I have to do is just have like a module? Am I understanding that correctly? Add a class, add a resource, add a reference, add a new item. I don't know. Sorry, I'm asking a lot of questions, but this is very new to me. I've never like done this before, so I guess we'll just try it. So we'll add a module. We'll call this shaders. So we're going to export the module of shaders. Just keep reading. They show you how it's done. Well, I thought that's what they implied here, right? The first thing we need to do is write a vertex shader in this language. Below, you'll find the source code and then compile the shader. Oh, is that like an intro? Oh, fuck me. Okay, never mind. Okay, back to normal. Let's keep reading. You have the GLSL code in a string and give it to the drivers. Okay, I'm sorry. I thought it was saying do this right now. Okay, my bad. Next, we declare the input vertex attributes in the vertex shader with the in keyword. Next, we declare all the input vertex attributes in the vertex shader with the in keyword. So those vertex attributes in the vertex shader, now we haven't called the vertex shader yet, but we already have our vertex attributes, which is this struct here. Now we don't have color or anything. This is just the float values of where they exist in 3D space. But obviously vertexes are going to be a lot more complicated than 3 floats later. Right now we only care about the position data, so we only need a single vertex attribute. GLSL has a vector data type that contains 1 to 4 floats based on its postfix digit. Okay. GLSL, the shader language, has a vector data type, so a container, that contains 1 to 4 floats based on its postfix digit. I think that what that means is that this container can only go, in terms of memory, like containing, it only contains 4 floats worth of memory at all. And it's based on its postfix digit. I don't know what that means. Since each vertex has a 3D coordinate, we create a vec3 input variable with the name aPosition. We also specifically set the location of the input variable via layout location equals 0, and you'll later see why we're going to need that location. Okay. It kind of lost me after postfix digit, but we'll keep reading. Vector refers to a mathematical vector, not the C++ vector. Oh, okay, I'm sorry. GLSL has a mathematical vector data type that contains 1 to 4 floats based on its postfix digit. Okay. Vector. Oh, here we go. Vector in graphics programming, we use the mathematical concept of a vector quite often, since it neatly represents position, directions in any space and has useful mathematical properties. So the mathematical properties is linear algebra, right? That's why linear algebra is so important to like computer scientists. Well, at least for game programmers for sure. Linear programming, discrete mathematics, these all matter a lot when it comes to like graphics programming, right? Yes, exactly. Sweet! A vector in GLSL has a maximum size of 4, and each of its values can be retrieved via vec(x), vec(y), vec(v), vec(w), respectively, where each of them represents a coordinate in space. So 3D, is that just 4D? I'm assuming vec(w). Oh, so XYZ coordinates. W is the next one? I didn't know that. I didn't know W was 40. Maximum size of 4 is different. I know that like colors and all that only go to max size of 1. And the resolution of the screen goes from -1 to 1. So it's probably the same thing, right? Respectively, where each of them are coordinate in space. Note that vec(w) component is not used as a position in space. We're dealing with 3D, not 4D, but is used for something called perspective division. Oh, never mind. Forget what I just said. We'll discuss vectors much greater depth in a later chapter. All right, perspective division. To set the output of the vertex shader, we have to assign the position data to a predefined GL position variable, which is a vec4 behind the scenes. At the end of the main function, whatever we set GL position to will be used as the output of the vertex shader. Since our input is a vector of size 3, we have to cast this to a vector of size 4. We can do this by inserting the vec3 values inside of the constructor of vec4 and set its W component to 1.0f. Okay, we'll explain why later. Okay. The current vertex shader is probably the most simple vertex shader we can imagine because we did no processing whatsoever on the input data and simply forwarded it to the shader's output. In real applications, the input data is usually not already in normalized device coordinates, so we must first have to transform the input data to coordinates that fall within OpenGL's visible region. Okay, that makes sense. So normally, in a video game of some kind, when you're the one making the video game engine for the designers to play around with to make the video game and fuck everything up with, you need to give them like abstractions of the code. I don't expect a designer like a level designer to know the in and outs of like OpenGL rendering, right? These are different like jobs. So my job as a engine programmer is to abstract, right? To create functions that do a bunch of things for the designer so he can do his job correctly. I would imagine that when like the level designer wants like a 50 by 50 pixel wide on any resolution square, right? I can provide him a function that allows him to input those numbers, and then I translate that to OpenGL language, which is like 0 to 1.0 in a float value, right? Because that's like its visible space. That's what I'm imagining it's saying here to the visible region. That's what I'm imagining what's going on here. Compiling a shader. We take the source code for the vertex shader and store it as a const C string at the top of the code file for now. That is disgusting. I have to save this as a raw C string and just quote this? That seems so not how you're supposed to do things. You can use raw string literals in modern C++. Oh, really? Okay. In order for OpenGL to use the shader, it has to dynamically compile it at runtime from its source code. The first thing we need to do is create a shader object, again referenced by an ID, so we can store the vertex shader as an unsigned int and create the shader GL create shader. Okay, so let's talk about this. So this, store the vertex shader as an unsigned int and create a shader. Vertex shader source. Okay. Compile shader under the shader with this vertex source. Okay, that's interesting. That feels so incorrect. So I know we can use raw string literals, but R quote parentheses end quote. Anything between the parentheses can be a multi-line string. Oh, that is based. So this, I would imagine we should probably put it before like anything. Do we want this to be global? I really don't want this to be global, but whatever, it'll be fine for now, I guess. So we are gonna do R parentheses and parentheses quote. Does that work? No, it doesn't. It doesn't work at all. Did I type that incorrectly? You placed the quote on the wrong... Oh, you're right. Thank you. Oh, look at that! Okay, sweet. I did not know you could do that. I'm gonna be totally honest. I didn't know you could do that. You learn something every day. Also, is this not supposed to be a pointer? Oh, it is a pointer. Oh my God, that is so dirty. I really don't like C. This feels super, like, not natural. Also, this shouldn't be a new line. dun, dun. I think that's it. Okay. That feels, oh, it feels so dirty. Whatever, it'll be fine. GLSL shader vertex shader. That feels dirty. Yeah, I don't need the /n. Already got it. All right, so this is GLSL stored as a string in a C array. Okay, Jesus. It's not an array, but a C string. All right, well, that exists now. All right. In order for OpenGL to use the shader, it has to dynamically compile it at runtime from its source code. So this introduces, this definitely is not an interpreter, but it's definitely new for me because I'm used to like SDL renderer, which is just load the game, right? I don't need to like dynamically compile anything. It just is, you know, it's just loading data. The first thing we need to do is create a shader object, again referenced by an ID. So we can store the vertex shader as an unsigned int and create the shader with GL create shader. Okay. I kind of want to just move this all to a new module. I should be able to do that, right? And then just export triangle. I probably should do that. Nah, whatever, it'll be fine for now. This is a tutorial. So we have an unsigned int vertex shader. Probably going after this. No, that's fine. Unsigned int. And this is going to be vertex shader. So now we're going to make a vertex shader object. Then with that vertex shader object, we're going to make it equal to GL create shader using what is the value? What was that? Extemper. Oh, I can't read your name very well. What is that name? Extemper Enesnon. Thank you for following. I appreciate it. Oh, I bet you didn't want that call out because you didn't say anything in chat, but you know what? Fuck you. You're getting a hello here. Hi. GL vertex shader. So that's new. We provide the type of shader we want to create as an argument to GL create shader. Since we're creating a vertex shader, we pass in vertex shader. Okay. That makes sense. So all we're doing here is we're making a vertex shader object and we're just telling it what kind we want, right? Ignoring the name, it could be anything, right? But we're gonna, whatever this is, it's gonna be a vertex shader in OpenGL language. We're just calling it a vertex shader, but we have to actually have OpenGL recognize that as such. Next, we attach the shader source code to the shader object and compile the shader. So we're taking that GLSL code we had here, this C-based C-string fuck shit, goddamn, this looks stupid, but whatever. We're gonna have it. Now we're gonna assign that to this object. Okay. So GL shader source. And then we're gonna take as input the vertex shader. And I'm assuming 1 is just the ID for it. Then we have the @vertex shader source. That is this guy. So now we're gonna use that and assign that here by reference because it's a string and we don't wanna send strings by copy, only by reference. And then null. So instead of passing, I don't know if it's like a me thing. I don't like to use null. I just like to use null pointer. To me, this is better. I don't know, it looks cleaner. It's a prettier color in Visual Studio, you know. And then we compile the shader, vertex shader. Okay, so now we're just going to call GL, compile the shader that we just made, vertex shader. Okay, so this is exactly, well, not exactly, but it's just like the buffer data that we made to give us memory space on the GPU and what kind of memory space we want. We're making a vertex shader object. We're telling it what kind of vertex shader it is and then compiling it. Null should be banned in any C++ code base. Based what the fuck, Blub? Man, Code Toil, WTF Blub, and oh, there's one more guy who's like super, super helpful. You guys know your shit. I can tell you guys are like programmers for a living. Okay. Hopefully I'm you one day. The GL shader source function takes the shader object to compile as its first argument. The second argument specifies how many strings we're passing to the source code, which is only 1. Oh, that's what that's implying. I thought it was like an ID thing. So if we have multiple strings we're passing as source code, that's what we have to put there. So that tells me it's a C-based library, right? I know OpenGL is not a library, but bear with me. Because in C++, you wouldn't have to specify like how many strings you're passing along, right? Am I interpreting this correctly? This is like a C limitation. The third parameter is the actual source code of the vertex shader, which is what we made in GLSL, and we can leave the fourth parameter to null. Yep. You probably want to check if compilation was successful after the call to GL compile shader, and if not, what errors were found so you can fix those. Checking for compile time errors is accomplished as follows. So this is newer to me. Not used to compile time errors in C++. I'm actually not a programmer for a living. I've just been programming since 2017, 2018 or earlier. Cool! So on int success, character infolog 512. So this is an array. This is a C-based raw ass fucking no condom array. Just raw dogging my eyes. And all it does is just gives you the memory to just have characters on the screen of some kind, or to have characters in memory. And then get shader riv, vertex shader compile status success. First, we define an integer, success, to indicate success and a storage container for error messages, if any. Then if the compilation was successful with get shader iv, if compilation failed, we should retrieve the error message with get shader info log and print the error message if success. Okay. We're good. We'll assume we're correct. What better way to program than only assume the happy path? Fragment shader. The fragment shader is the second and final shader we're going to create for rendering a triangle. Oh, 2 more steps and we got ourselves a triangle. You know what, chat? I think people overstated how difficult OpenGL was. You guys are all, well, I say you guys. Generally, I always heard that like OpenGL, I don't know about Vulkan, but like OpenGL is like super syntax heavy and it's difficult, but it's not that hard to understand. Yeah, the most difficult part I had was linking the library to like have a wrapper around GLAD and all that stuff. But once we've had the library, it's not that hard to understand, right? Yeah, it's an OpenGL to clear and swap window and stuff, but like you did that in SDL anyway, you just called SDL functions. So the only thing that's new is you create memory on the GPU. That's all this step is right here. Then you create a vertex shader and define, you know, it's defined. This is all we're doing, right? Make an object that's defined as an OpenGL vertex shader. Give it the GLSL source code you made with one statement and then compile it. There you go. That's you just made a shader, right? It's not that hard.
OpenGL is easy. The only thing people struggle with is the global state. Well, I mean, I understand what the global state is. I don't know what the difficulty is with managing it because we haven't really managed it yet much. I mean, we made it, but we haven't really done anything with it. Besides, like, render a color onto the screen. That's really all we've done, but you know, I'm sure we'll have our difficulties. But the actual like process of learning OpenGL, it's just, if anything, it's just knowing the graphic pipeline. Like once you know the graphic pipeline, you're just learning the functions to like how to do it. It's just an API, you know? Sorry, I'm getting kind of nasally. I don't know, I like it so far, but you know, I also like C++, so verbose language gets me hard, you know? The fragment shader is the second and final shader we're going to create for rendering a triangle. Wow, I am so nasally right now. It sounds like I can't even breathe through my nose, cause I can't. The fragment shader is all about calculating the color output of your pixels. To keep things simple, the fragment shader will always output an orangish color. Now, that's interesting. I wasn't expecting a color with this triangle because all of my data in every vertex is just the three-dimensional space in which that point exists in. I was assuming that if you're gonna have a color, it would be like GL, color, and then you give it some data, right? Or color, or something like that, right? I thought that would be required to have a color, but I guess not, so hey, learned something. Colors in computer graphics are represented as an array of 4 values, RGBA, commonly abbreviated to RGBA. When defining a color in OpenGL or GLSL, we set the strength of each component to a value between 0.0 and 1.0. We already did this when we created the background color. We casted these as GL floats because otherwise you get warnings, and warnings just are they trigger me. I don't like warnings. Fuck warnings. I like it when I compile something to have no warnings, okay? I know that will probably never happen, but it's a nice goal. No, you are right. That's exactly how it's done. This tutorial just hard codes the color in the shader in the beginning. Oh, okay, sweet. 0.2F? What do you mean 0.2F? What do you mean? Coconut dev, you can't just drop in here with your coconuts and just, I was trying to think of something funny, chat. I'm not that clever of a streamer. And just say 0.2F. who does 0.2F? What nerd does that? Okay, I'll do 0.F to make it a float point value, but 0.2F? That's disgusting. That indicates it's a float and not the double? Oh. Well, that would make sense if I didn't have an explicit casting of GL float right in front of it, but I get the spirit of it. If I didn't have this, yeah, I would probably do that. No, I wouldn't do that. Also, I pressed the wrong button and I hate my life. Okay, I wouldn't do that. I would do... No, I would cast it as a float. I would do that. This to me is more clear about what I want. If it's important enough for me to explicitly like cast something as something, to me this is more readable than 0.2F personally. Now I'll do like 7.F because that's fine. It's a float point value, right? I think 7.F is fine, but if it already has a decimal in it, casting it as float, I think that's better. For me, that's more readable. And to me, I bow to the throne of readability, okay? I'm an always auto freak. Fragment shader. The fragment shader is the second and final shader we're gonna be... Hold on, speaking of always auto. Oh, that's why. I was like, wait a second, where's my warning coming from? Speaking of always auto, there's something I have to do here. I wonder if this works. Auto, unsigned int. Okay, that is more readable to me. Type name not allowed. I wonder why that doesn't work though. don't know. It always confuses me when unsigned is allowed in C++, because this allows you to go auto vertex shader equals unsigned int, but not this. Oh, you know what? I lied. Hold on. I lied. Curly braces. I love always auto. If it helps, fragment shader in DirectX is called pixel shader, which I think is a little more benefiting. No, I like fragment shader more because I don't like the term pixel shader because to me in my head, a pixel shader shades individual pixels, but that's not what OpenGL does. It doesn't, well, you get what I'm saying, right? I don't care about individual pixels so much as the shader shading some part of the screen correctly, and then depending on the resolution of whatever monitor it's on, will color certain pixels differently at any amount of pixels. Does that make sense? Sleepy Mushroom, hello there! Whereas if I hear like a pixel shader, I hear like SDL or something where I'm explicitly telling you how many rows of pixels, regardless of resolution, to color. A fragment shader is ran for each pixel that's a primitive is filled in for. Okay, well, I have no experience with DirectX. Remember, okay, I'm learning OpenGL. We're doing this because I have a class. So how far are you into learn OpenGL? We're about to draw a triangle. And by about to, I mean, we're getting there. Remember, I started programming in like super late January, okay? So this is, I speak with confidence of somebody who's only spent like 5 months programming, if even, like 4 months, 4.5 months, right? I have classes relating to programming because I'm going for a computer science degree, but like that's the limit of my experience, okay? All of my programming experience has been in C++ only, okay? I don't have experience with like JavaScript or XML or whatever the fuck you kids use these days. Scratch. All of my experience is C++, so there you go. Also, always auto is based. I remember when I asked an instructor in my gymnastics program about how to make a 3D graphics using Batch, he told me you can't, but you can Wii Java. Oh my God, he had a stroke. Oh no, that poor gym teacher. Scratch QWQ. Ah, I like Scratch, it's adorable. It's like, it reminds me of old Flash games on Congregate. Like Elements the game. All right. Okay. So version 3.3 core main frag color. So this is gonna go. So obviously I'm not gonna do this right now, but this is also going to be a string. And then we're gonna make a C string. Sorry, to be clear, a C string object that's right now global, but it's going to go into a module at some point called shaders. And it's going to be saved the same way. So every time I see this version 3.3.0 core, whatever, that to me in my head, I just see shader. Okay, which is a separate language. Actually, wait, it was not 3D graphics. It was adding an image. Oh, cool. The fragment shader only requires one output variable, and that is a vector of size 4 that defines the final color output we should calculate ourselves. So out vec4 frag color. So this frag color variable is probably no, it is a changeable color, or sorry, a changeable variable name. It's a variable. In this case, we have a vec4, so we have a size 4 math vector that defines a color value, and this color value is 1.f, 1.0f, 0.5f, 0.2f, 1.0f. So this is R sub G little b. So this is like yellow? I think this is yellow. I don't know. I don't know colors that well. Oh no, he said orange. I'm sorry, it's orange. The tutorial said orange. 1.0f here, that's the that's an alpha value, so it's visible. 0.0f would be completely transparent. I wonder if you have to tell the state of OpenGL to enable blending in graphics. I don't know if you, I know in the SDL renderer, you do have to explicitly call a function to change the state of that renderer to allow alpha blending, but I don't know if it works the same with everything. The fragment shader only requires one output variable, this, and that is a vector of size 4 that defines the final output ourselves. Frag color, assign a value. Okay. Fragment shader source. Okay, so it's the same thing. So we're gonna copy, because I don't want to get all the way into vertex shader, vertex color shader, and this will be a const character pointer vertex color is equal to capital R quote beginning parentheses enter end parentheses end quote semicolon. Cool. Yes, you do have to do it with OpenGL. Oh. No size T or size in shader. Shaders don't need very long variables, but can have it. Oh, cool. The fragment shader only requires one output variable, and that's the size. All right. The process for compiling a fragment shader is similar to the vertex shader, although this time we use GL fragment shader constant as a shader type. So as I understand it, chat, this is how I think what's going on here. We have our buffer, we have our vertex shader, and then we have our fragment shader, not pixel shader. We can use them interchangeably, but for my brain's sake, we're just gonna call it a fragment shader. Now we're gonna make our fragment shader, right? So auto, I'm gonna get as far as I can without looking at the tutorial. Fragment shader is equal to unsigned int GL create fragment. Fuck. Okay, we got as far as I could. And then we have a fragment shader. Now as I excuse me, Jesus. As I understand it, this buffer for every object that OpenGL will ever render in any context at all, I must go through all of these steps for every object, right? Now I can group objects in like an array and maybe do something like that, but ignoring that, every object has to go through this process. Reserve space on the GPU and tell it where on the GPU you want that space reserved, so really, really fast memory or not. Then we have to shade all of the vertexes that are going to be visible, potentially visible on the screen. Then we shade all the fragments that are associated with those vertexes, yada yada, right? It's probably still GL create shader. Oh, is it? Fragment shader, create shader. Oh, really? Okay, I guess that makes sense, right? Because we're still using the GLSL language. Color shader. That was not the term, hold on. Fragment shader, fuck. So I guess my question is, can I skip the fragment shader or something like that? Can I only do vertex shaders and then move on to the next step? Not that it matters, but there you go. Sorry for complicating things. Oh no, don't worry. Dude, chat, I swear to God, Coconut Dev, you are like another example of this. You guys all sound like abused puppies when you first come to the stream. I don't know what these other streamers did to you, but like, I'm not gonna pull up your comment history and be like, you've been subscribed for a year, you fucking idiot. Like, I'm not gonna like call you out, okay? I allow backseat gaming, or backseat programming even. But my only thing is you can't get mad if I don't listen to you, okay? You can't get mad. That's my only requirement. But you can backseat all you want. Yeah, no, I'm a firm believer that, I'm a firm believer that you guys are like, streamers are too mean. I think streamers need a reality check. I think they are the luckiest people
to like ever exist. And they're just so mean. They're just so mean to like their audience. I don't get it. I don't understand. Why be so mean? Like, I understand part of it is like, I understand part of it is just, am I dumb? What am I doing here? Shader source. Oh, we have to call the function. Okay, my bad. No. No, what do you mean no? This is for the fragment shader. And then we call 1. And then we call our referenced value of vertex color. And then our last term, don't tell me. Is it null pointer again? That's my guess, is that this is null pointer. Oh, yeah. And then compile the shader. By the way, the UI for Visual Studio is kind of messed up. Normally, if I was programming on my own, by the way, without you guys watching this, I would be at like here. This is what I would be. This is like where like my readable thing, because I have a huge monitor. This text is very readable to me. So just so you know, this is for you, all right? So that's why the UI is all kind of messed up, because we're super zoomed in. Playing a character, but also I don't usually watch live streams. Oh, well, hey, thank you for watching mine. I appreciate it. In DirectX, you can skip the fragment shader if you're only rendering scene depth to a texture. I'm not sure about OpenGL. I don't know if it's because like it's a pride thing or if it's because I'm actually... when I make programs, I want there to be as little dependencies as possible on the user's end, right? That's why I don't like Java or like Python or any sort of interpreted thing. I love the idea of like a program that is compiled on my end and it's like a .exe and it just works. You click it and it does what it says on the tin. I really, really, really like that. So like this idea of like, oh, the user needs to have this driver on their video card of this version in order for you to have access to this function. I don't know. I don't like it. It feels very unintuitive, not consumer friendly. It's one of those things that as I get into, sorry, I can't breathe through my nose at all right now. As I get into the industry, because I'm getting a degree, right, in computer science, I'm going to be in the industry, whether it's in video games or like, in applications or whatever I end up doing in software. I really want to push for like, hey, let's not put any of the dependencies as the user's burden. Let's just have you click it and run it. And it's just, it's so nice to me. I really like that feeling. Whenever something just works. Excuse me. Okay, both the shaders are now compiled, and the only thing left to do is link both shader objects into a shader program that we can use for rendering. Make sure to check for compile errors here as well. Oh. God, I love being good at programming. That's what the job of software engineers is, I believe. Hey, if we had it my way, I would make a, what would I do if I had unlimited skill and unlimited time? I would make a C++ compiler that just uses modules as a base, like imports, and you can't hashtag include at all. It must be imported. That's what I would do if I had the time and skill. I would just make a dedicated modern C++ compiler and just throw like backwards compatibility out the window. Then I guess that doesn't make it C++ anymore, but you catch my drift, right? You would love apple beige then? If I was a mage, I would be an orange mage because I like creamsicles. I'm sorry, chat, I keep coughing in the microphone. I don't know what it is. I just can't breathe right now. Shader program. This is new to me. A shader program object is the final linked version of multiple shaders combined. To use the recently compiled shaders, we have a
we have to link them to a shader program object and then activate this shader program when rendering objects. To use the recently compiled shaders, which is our vertex shader and our fragment shader, whoops, we have to link them, so probably link them by pointer or reference, to a shader program object and then activate this shader program when rendering objects. Okay. The activated shaders will be used when we issue render calls. When linking the shaders into a program, it links the outputs of each shader to the inputs of the next shader. This is also where you get linking errors if your outputs and inputs don't match. Creating a program object is easy. Unsigned int, GL create program. Oh shit. So auto shader program is equal to another unsigned int. Man, a lot of unsigned ints. I did that wrong. GL create program. Oh, I thought it was shader program. My bad. Okay, beautiful. Excellent. So now we have a shader program. It just exists now with no parameters. All right. App image, not Apple Mage, respectively. Oh no, it's getting called Apple Mage forever now. Now that I think about it, I think OpenGL can draw without a fragment shader. The color just defaults to black or white. Is there any kind of video game or any kind of effect that would benefit from the saved memory or time by not having to render any fragment shaders? Is there anything you could do? Like maybe some weird, like, not ellipses. You guys know what I'm talking about? Like you're looking through like those old toy like image things and you like twist it and it turns into like pretty triangles and colors and all that, except you could do that with just black and white. Yes, depth pre-pass. I don't know what that means. Are you talking about like texture shit? Remember, 4.5 months of programming and a lot of that was spent on like a card game and a bullet hell shooter, okay? appleimage.org. Linux apps that run anywhere. Look, it's Mr. Linux. Oh shit. Mr. Linux gets very angry. I know that about him. Even I know that is an angry man. All right. The GL create program function creates a program and returns the ID reference to the newly created program object. Now we need to attach the previously compiled shaders to the program object and then link them with GL link program. Oh, that's easy. GL attach shader, link program. Oh, that's easy. Okay. So GL attach shader. This is where I would imagine we would like iterate through an array or something and just have that value here. What was first? Oh my God, GL uint. Okay, the shader program is first. Shader. And then we pass by not reference vertex shader. I will say it is a little weird to be making, I guess an unsigned int isn't that big of an object, so we don't really need to pass it by reference, but it is weird to pass a lot of these things by not reference or pointers or anything. And then we'll pass our fragment shader and then GL link program with shader program. All right, that makes sense. We'll go over everything once we're done with this link program step, but Everything, again, I've already said this before, all of this makes sense. It's like, yeah, it looks complicated because we're calling a bunch of functions, but I mean, think about what we're doing. Look, reserve memory on GPU, then make vertex. No, I shouldn't even say make. Apply vertex shader. Apply fragment shader. Create program to manage shaders. That's all we're doing. It's like super simple steps every step of the way. Yeah, the syntax is ugly, but I'm a C++ programmer. That's what we do, you know? You can benefit from that technique so you don't have to calculate lighting for pixels. That won't be occluded. Oh, cool. Didn't know that. The code should be pretty self-explanatory. Yep. Just like shader compilation, we can also check if linking a shader program failed and retrieve the corresponding log. However, instead of using get shader IV and get shader info log, we now use that error, which we won't do because we program happy, baby. And no errors. All right. The result is a program object that can activate by calling GL use program with the newly created object as its argument. Ooh, I wonder if that means that we call this every frame. Probably not, right? We just need to make it. So it will now use this program object and thus the shaders. And then don't forget to delete the shader objects once we've linked them into the program object. They are no longer need them anymore. Okay, sweet. So, I mean, these are just strings, but you know. Oh no, they're not even strings. They're unsigned ints. There you go. Save your 16 bytes, you fucking moron. Did he not read the correction? Never do, baby. You call it before the draw calls you want to use those shaders for. Ah. So, GL, use program, shader program, and then, man, there's a lot of repeating myself here. I feel like we could make a hella quick function out of that. And then, delete shaders. GL, I'm assuming it's delete shader. So we're gonna delete vertex shader, GL, delete shader, and we're gonna delete the fragment shader. And we're deleting these because we already have a program object with the information in there as like info to call later. We don't actually need these unsigned ints anymore, so that's worth considering. All right, so deleted them. Right now, we send the input vertex data to the GPU and instructed the GPU how it should process the vertex data with shaders. We're almost there, but not quite yet. OpenGL does not yet know how it should interpret the vertex data in memory and how it should connect the vertex data to the vertex shaders attributes. We'll be nice and tell OpenGL how to do that. All right. You can benefit from that technique so you don't have to calculate lighting for pixels to be occluded. Cool. Linking vertex attributes. The vertex shader allows us to specify any input we want in the form of vertex attributes. And while this allows for great flexibility, it does mean we have to manually specify what part of our input data goes in which vertex attributes in the vertex shader. Okay, hold on, what? The vertex shader allows us to specify any input we want in the form of vertex attributes. And while this allows for great flexibility, it does mean we have to manually specify what part of our input data goes into which vertex attributes in the vertex shader. Okay, that makes sense. So what they're saying is that when earlier on we created a struct. Right now, these are just float values, right? They just exist in just this. There's nothing else. Now, later we can have like a color value associated with the object or whatever else information we want vertexes to have. Right now it's just 3D space, right? But if this did have like a color of some kind and we had like color, whatever that means, right? If we had our colors here, what this would do is when we added the memory to the GPU and the shaders and everything, OpenGL doesn't actually know what the individual data is. It just sees float point values. So what we're doing, or about to do, I guess, is we're gonna take this vertex shader or fragment shader, whatever we're gonna do, and we're gonna tell OpenGL how to interpret the data inside of it. In this case, how to interpret these XYZ float point values, right? What do these numbers mean in the vertexes? So that's what we're gonna do next. As you're reading these sections, my mind just immediately goes to translating it for DirectX. Ah, cool. Honestly, the only thing I know about DirectX is I always need to install a version of DirectX that, like, no matter what, I just need to install a new version of DirectX. Like, I could install the original Diablo 2 and just the fucking Battle Chest version on CD, and it would still tell me to download a new version of DirectX. It's just, they are never satisfied. They always want more installations. It's like a fucking conspiracy. Shadertoy.com. Build and share your best shaders the world and get inspired. It's just loading screens, chat. All this is loading screens. Oh God. Okay. Oh, geez, there we go. Oh, it's Tetris. Oh shit. Oh, there. Oh, hold on. It's hard to do on arrow keys. 1 second. Shit. Hold on. I'm good at Tetris. 1 second. Go. Down. Hold on. I'm gonna get a Tetris. Shut up. No. Fuck. God damn it, chat. You fucked me. It's okay. We'll get out of this. This is so hard to do on keyboard. Holy shit. Shit. God, it's so hard to do on keyboard. It's like I go down way too much. I WASD? Nope. Shit. If you think I'm not gonna play this whole game. Oh my God, my fingers are starting to hurt because of how much I have to press my up key. Yeah, this is the stream now. Deal with it, okay? This is your life now. Shit, that was really dumb. Oh, did they ever loop the thing? Did they ever like loop it? You know what I'm talking about? God, Tetris is so hard. What the fuck? Oh my God, I'm so fucked. I'm so fucked. Hold on. I can beat this. Shit, fuck. God damn it. Okay, whatever. It's hard to do on arrow keys, okay? God damn it. Ow, my hand hurts now. Boss, trust me, I'm working on our new project. Hey, we're learning about shaders, okay, chat? Also, that was a fun game. The vertex shader allows us to specify, oh yeah. This means we have to specify how OpenGL should interpret the vertex data before rendering. All right. Our vertex buffer data is formatted as follows. Vertex 1, vertex 2, vertex 3, bytes, 0 to 12, all the way up to 36. Okay, I'm a little confused about the byte information because we used float point values, right? Float point values are not 4 bytes, right? Floats are 4 bytes wide. What the fuck? No, integers are 4 bytes. Hold on. Learn CPP! Come to my rescue! Hold on. Integer. Oh my God! It is 4 bytes. Oh shit. Okay, my bad. I was thinking it was a long double, I guess. I thought it was 16 bytes for whatever reason. Wow. You learn something every day. Size of float? Nah, I can look that up. Thank you. Okay, my bad. Sweet, based. Each position is composed of the 3 of those values. There is no space or other values between each set of 3 values. The values are tightly packed in the array. The first value in the data is at the beginning of the buffer. Now, that array that they're talking about is this. So we have a struct called shape, which is just a standard array of 3 vertexes, shape array. So we create a triangle using the V1, V2, and V3, which are vertexes, as its information. So that in the array is this visualized. So it's 3 sets of 3 floats that equal 36 bytes. The first value in the data is at the beginning of the buffer. Yep. Okay. With this knowledge, we can tell OpenGL how it should interpret the vertex data per vertex attribute using GL vertex attribute pointer. Okay. So GL vertex attribute pointer, 0 to start, 3 is where it ends. These are GL float point values, something true or false, 3 times size of float, probably the total size in bytes of the array, and then void 0. The function attribute pointer has quite a few parameters, so let's carefully walk through them. The first parameter specifies the vertex attribute we want to configure. So let's do this step by step. Attribute pointers. GL vertex attribute pointer. GL vertex attrib pointer. And then we're gonna call a bunch of things. First thing, at which point the vertex value we want to configure. Remember that we specified the location of the position vertex attribute in the vertex shader with the layout location 0. Oh, here. Layout location equals 0 in vec3a position. Oh, so it's all coming back. All right, sweet. So 0 is where it starts. This sets the location of the vertex attribute to 0. Since we want to pass this vertex attribute, we pass in 0. Why am I so like today? I'm like nasally, I can't breathe in my nose, I'm hiccupy. A position, I believe, is the prefix for attribute. Did you just call that attribute a piece of shit? I see what's going on. Okay, all right. Floats and doubles are the same size of 2 or 1 ints, depending on the computer's architecture, and 1 long respectively. Yeah. Okay, I gotta remember that. Actually, it's really important I remember that, because if these aren't float point values, this changes, right? If these are just integers. Although I guess if they're integers, then it would just be, they wouldn't even be visible because it would be on the outside view port of like the screen. The next argument specifies the size of the vertex attribute. A double is 8 bytes, which is why some languages or sources define them as F32 and F64. The vertex attribute is a vec3, so it is composed of 3 values. 3. The third argument specifies the type of the data, which is a GL float. Vec star in GLSL consists of floating point values. Okay, so GL float, which is undefined. Oh, it's 1 word. GL float. Oh, maybe not. Oh, is this like a flag? Oh, it is. Oh, interesting. I didn't know there was a difference between GL float, 1 word to specify a float point value, and GL float like the flag. All right. On 32-bit computers, ints are 2 bytes long. On 64-bit computers, ints are 4 bytes long. Okay. The next argument specifies if we want the data to be normalized. We are inputting integer data types, int, byte, and we've set this to GL true. The integer data is normalized to 0, or -1 for sign data, and 1 when converted to float. This is not relevant for us, so we'll leave it at GL false. Okay. I don't know when that would turn true, but I'm just going with the flow right now. Going with the float right now. Oh, no. If you want a better tutorial, learn CPP. If you guys have never seen this website, I think it's regarded as just the best source for learning C++. It is so good. Highly recommend. My only thing is they have debugging as chapter 3. I feel like debugging should be like chapter 10. Seems really early for like learning debug tactics when you don't even know like what a data type is. But, you know, that's there. Besides that, I think it's a great resource. Up to date, modern. The fifth argument is known as the stride, and it tells us the space between steps if you're a manly person. Space between consecutive vertex attributes. The next set of position data is located exactly 3 times the size of float away, since we expect that value in the stride. Ah, I got you. So, right now, every vertex object is 12 bytes of memory long. These 12 bytes are because there's 3 float point values, each of which is 4 bytes. But how do we separate in the array how much memory every vertex object takes? Well, it's 12 bytes. So that's what I think why we're gonna do here. Where's my thing? Okay. Ooh, no, not that. Where's my, there it is. Comma. No, not that one. Comma, 3 times size of, parentheses, float. So that's why this is a parameter, because 3 times size of float is the size of a single vertex object. It contains the exact same amount of memory. So that's how much it knows between every step in this graph here, every vertex, where the new vertex starts and ends. Note that since we know the array is tightly packed, there's no space in between the next vertex value, we could have also specified the stride as 0 to let OpenGL determine the stride. This only works when values are tightly packed. However, we have more vertex attributes. We have to carefully define the spacing between each vertex attributes, but we'll get to more examples of that later on. Why not just use size of vertex? Because, you little bitch, don't stress about it, okay? We're getting there, all right? This looks cleverer anyway. This looks really lame. But you know what? We're learning, all right? Also, hi, Raymarch. It says it here. Yep. All right. The last parameter is of type void pointer and thus requires that weird cast. This is an offset of where the position data begins on the buffer. Since the position data is at the start of the data array, this value is just 0. We will explore the parameter in more detail later on. And what it does is casts a 0 as a void pointer. Okay. Wow, this is so C looking. Cool. And there's our function. That is... It's a simple function though, right? Like, again, it looks verbose, but the actual thought of it is simple. 0, because in our GLSL language, we have location equals 0, so it's 0. 3, because we have, 3, I think there's 3 objects in the array. I think that's what that's implying. Then these are float point values. False, because we'll worry about that later. The size of every individual object in that array, which in this case is 3 times the size of a float point value, so 12 bytes. And then this, which we'll worry about later, which like, that's pretty simple, right? So now, to go through it step by step again, what happened, right? We reserved memory on the GPU. We applied a vertex shader. We applied a fragment shader. We made a program that contains that data and we can use it in other ways later. Then we delete those shaders in order to kind of give us room on the computer, right? And then we just tell OpenGL what those numbers actually mean. That's all we're doing so far. Yeah, it's verbose, but the thought of it is simple. The only case where int would be 16 bits should be on a 16-bit. architecture? I don't know. MSVC compiler by default int size is 32. Last time I saw a 2-byte int was back in the DOS days with a 16-bit compiler. Based. All right, next. Linking vertex attributes. So I think this is the last step, and then we just render a triangle, right? Each vertex attribute takes its data from memory managed by the object, managed by a VBO, and which VBO, the buffer, and it takes its data from, you can have multiple VBOs, is determined by the VBO currently bound to the array buffer. When calling vertex attribute pointer, since we previously defined VBO is still bound before calling the attribute pointer, vertex is now 0, now associated with the vertex data. Yep, it's all obvious. Basically, if you did everything right, it's all just taking care of itself, and we can give more complicated examples later. But for the purposes of like rendering a triangle, it's not that hard. Unless specified earlier, VBO stands for vertex buffer object. I just call it the buffer. Probably not the correct language, but it's a buffer object. Now that we specified how OpenGL should interpret the vertex data, we should also enable the vertex attribute with enable vertex attribute array. Oh, so we just turn it on. Giving the vertex attribute location as its argument, vertex attributes are disabled by default. From that point on, we have everything set up. We initialize the vertex data in a buffer using the vertex buffer object, set up the vertex. Okay, it just repeated what I just said. Drawing an object in OpenGL would now look something like this. So, copy our vertices array in a buffer for OpenGL to use, set the vertex attribute pointers, use our shader program when we want to render an object, now draw the object. We have to repeat this process every time we want to draw an object. It may not look like that much, but imagine if we have over 5 vertex attributes and perhaps hundreds of different objects, which is not uncommon. Binding the appropriate buffer objects and configuring all vertex attributes for each of those objects quickly becomes a cumbersome process. What if there was some way we could store all these state configurations into an object and simply bind this object to restore its state? Vertex array object, VAO. Oh shit. Hold on, I'm turning more music. There we go. Shit, wrong button, sorry. That's Tetris. Nah, we listened to that before. What's this one? Ocarina of Time? Based. Vertex buffer works since there are things called index buffers too. Ugh. Vertex array object, VAO, can be bound just like a vertex buffer object, and any subsequent vertex attribute calls from that point on will be stored inside of the VAO. This has the advantage of that when configuring vertex attribute pointers, you only have to make those calls once, and whenever we want to draw an object, we can just bind the corresponding VAO. This makes switching between different vertex data and attribute configurations as easy as binding different VAO. All the state we just set is stored inside the VAO. Red, core OpenGL requires that we use a VAO so it knows what to do with our vertex inputs. If we fail to bind a VAO, OpenGL will most likely refuse to draw anything. Holy shit. A vertex array object stores the following: calls to GL enable vertex attribute array or GL disable vertex attribute array, vertex attribute configurations via attribute pointer, vertex buffer objects associated with vertex attributes by calls to vertex attribute pointer. Okay, that's simple, right? So we have a VAO and a VBO. So we have a VBO already. We made that already. These positions are the object information that we already put in. A stride is one from one to another. A VAO contains attribute pointer 0, attribute pointer 1, 2, so on and so forth. And then VAO2 is attached to a separate VBO. Okay, that makes sense. With longer strides if needed. Okay. The process to generate a VAO looks similar to that of a VBO. VAO. Do I need to type in this first? I don't want to do that yet. I know, some OpenGLF function that draws our triangle. Okay, so it's like pseudo text. I got you. All right, next.
Input layout in DirectX. Oh no. The process to generate a VAO looks similar to that of a VBO. Unsigned int VAO gen vertex arrays at VAO. So it's very similar. So VAO vertex attribute operator? Vertex array object. Holy shit. Auto, what were we doing? Auto VAO unsigned int gen vertex arrays. Gen vertex arrays 1. The reference value. Oh, it's an unsigned int. Shit. Unsigned int. There is no shot this actually works, right? Yeah, I can't do that. Yeah, I can't do that. I got greedy, chat. I was like, can I do it? Can I? Maybe. Okay, so that's our function. Sweet. Uint 32. No. To use a VAO, all you have to do is bind the VAO using bind vertex array, which we just, oh no, we didn't, we generated it. From that point on, we should bind such configure the corresponding VBOs and attribute pointers and then unbind the VAO for later use. As soon as we want to draw an object, we simply bind the VAO with the preferred settings before drawing the object, and that is it. In code, it would look a bit like this. Okay, bear with me here. Initialization code done once unless your object frequently changes. We already have all of our initialization here. Bind vertex array object. So bind vertex array, VAO. Okay, now we generated it, we binded it. Copy our vertices array in a buffer for OpenGL to use. So GL bind buffer. Using the enumerated value, which I forget which one we're going to do there. GL array buffer VBO. GL array buffer VAO. Okay, that looks similar to GL gen buffers, bind buffer, GL buffer data. GL gen vertex arrays, bind vertex array, bind buffer. So it's kind of like a roundabout way of making the same thing. And then GL buffer data. Okay, so this is super similar to the other one. Interestingly, it's static draw and not stream or dynamic, which I think that means it's the second fastest, right? Yeah, it's the second fastest. Okay. So GL buffer data. And in this, we're going to call array buffer again. This time, though, we're actually going to be calling the size of it. So it's size of int, right? Oh, vertices. Fuck. Size of vertex, which is just float times 3, but I guess we'll just do something different this time. That's the steps. Remember, that's from one step to the other. I believe that code is just a reiteration of what you wrote before. No. This is VBO. Before it was God damn it. Ah, you're right. Oh, God. Size of the entire array. Oh, my God. Shit. Oh, you're totally right. Fuck. Okay. God damn it. All right. Ugh. So what is this then? That's there. Okay, so this is here, but not these? Static, floats, enable vertex attribute array. So we didn't do that. Zero. Because we're at location 0, right? Okay, drawing code and render loop, and then draw the object, and that's it. GL use program. Okay, so now we're gonna come down here. Oh my goodness, we're actually drawing. So GL use program. No, it's shader program. And then bind vertex array. VAO. And then some OpenGL function that draws our triangle. What the fuck? And that's it. Everything we did in the last few million pages led up to this moment. A VAO that stores our vertex attribute configuration, which VAO to use. Usually when you have multiple objects you want to draw, you first generate, configure all of the VAOs, and thus the required VBO and attribute pointers, and store those for later use. The moment we want to draw one of our objects, we take the corresponding VAO, bind it, and then draw the object and unbind the VAO again. Okay. Did the guide you're following not make you draw a triangle before having shaders? Oh, Coconut Dev, you can't draw a triangle without shaders. You have to have shaders. It's required. Ooh. The triangle you've all been waiting for. To draw our objects of choice, OpenGL provides us with GL draw arrays function, which draws primitives using the currently active shader, the previously defined vertex attribute configuration, and the VBO's vertex data indirectly bound via the VAO. All right. Geez, we can go over every step in the process, but it's pretty easy, right? Use program, vertex array, GL draw arrays. GL draw arrays using GL triangles. Okay, I don't know what that means. Zero and 3, because that's the information we fed the array earlier. GL draws arrays function takes as its first argument the OpenGL primitive type that you would like to draw. Since I said at the start we want to draw a triangle. Oh, that's right, because they discontinued like squares and rectangles and it's only triangles. Right. It's like an outdated thing. I saw your human mask, and I have to say, I'm glad you took that Halloween mask off. Aw, Teddy the cat says, I'm glad you enjoyed my flesh tube. My flesh tuber. My flesh tuber. I'm glad. Thank you. I appreciate it. It's once in a blue moon, but, you know, sometimes a stream IRL. And I don't like, I said at the start we wanted to draw a triangle, and I don't like lying to you. We pass GL triangles. The second argument specifies the starting index of the vertex array we'd like to draw, leave it at 0. Last argument specify how many vertices we want to draw, which is 3. I only render one triangle from our data, which is exactly 3 vertices long. Now try to compile the code and work your way backwards if any errors pop up. As soon as your application compiles, you should see the following. All right, if everything worked, I'm gonna press the compile button, and this is what we see, except the background's gonna be a little more teal. That's the only difference. So, here we go. Shit. That's not good. Okay, the first thing I saw earlier was this. Size of triangle. I think that should be size of vertex. Nope, I fucked something up. God damn it.
Okay, okay. Where did we screw up? We screwed up somewhere. We screwed up somewhere. Source code can be found here at no. God damn it. Okay, what did I miss here? Okay, well, let's work backwards. Turn on the camera, please. Not today. Maybe tomorrow. I'm okay with it. It's just, I'm not in the mood to turn on the camera today. I gotta, like, replug in the back of my computer to get the camera working after a computer reset. For reasons. You forget the triangle? Oh, thanks, Teddy. Thanks for that. I appreciate it. All right, so let's work backwards here. So GL triangle 03 VAO shader program. Okay, we did all that. So this is something I skipped. Oh, I did skip this step. Somebody said it was a repeat, but it's not. Okay, so let's just copy this and paste it here. Okay. So, vertices, this should be vertex. Vertex. Vertices, no. I know what happened. That's the name of the array. There we go. This is my referenced value. Okay, so now let's see if it works. There we go! Oh! Chat, we have a problem. Why isn't it orange? Why is it white? So the color didn't render, but at least we have a triangle. Well, there we go. But there's no color. So the fragment shader didn't kick off. Interesting. But it worked. Print screen. Hold on. We're gonna smile with it. Say cheese. Ah! I think I saw an error in your fragment shader, so you're getting a default color of white. Oh, cool. Well, we'll solve it tomorrow. All right. Remember, I have a Discord linked below the stream if you guys want regular updates about what's going on and updates on video game elements of the game and anything else. I'm always available on it whenever I'm on my computer. So I'll see you later, guys. I stream every single day. Tomorrow, we go beyond triangles. We draw element, but whatever was next in the tutorial. We have our triangle. Oh my goodness. And we're going to be back tomorrow. So I'll see you Kit Kats tomorrow on the flip side. Have a good night. I'm not going to raid anyone. Find your own entertainment, chat. See you later, alligators. Oh, and I'll do IRL streaming tomorrow because people asked for it. Goodbye.